Chapter 18, Review for Test. The multiple choice. Number 1. A 30 ohm resistor and a 60 ohm resistor are connected in an electric circuit as shown below. Compared to the electric current through the 30 ohm resistor, the electric current through the 60 ohm. So when I look at these, the first thing I'm going to see is that going through this wire, the current going through here is the same as the current going through here, which means they're in series. So when they're in series, the current is the same, and that's it. So that's how fast it should take me to do that question. So the answer there is C. Number 2, the potential difference. So remember, potential difference is the voltage between points A and B in the electric circuit is 10 volts. So that means the voltage across this resistor is equal to 10 volts. What is the voltage between B and C? Okay, so if I know the resistance and I know the voltage, remember, once I know two things, I can find a third. So Ohm's law says V is equal to IR, so I is equal to V over R, so 10 divided by 10 is equal to 1 amp. So the current going through this resistor is 1 amp. I see that these two resistors are in series. So if the current going through here is 1 amp, that means the current going through here is 1 amp. And now they say, what's the voltage between B and C, which is the voltage drop across this resistor. So if I'm given I and I know R, I can find V. So V is equal to IR, so it's equal to 1 amp times 20 ohms, which is 20 volts. And you see with all these calculations, I didn't even need to use a calculator. These were easy enough to do in my head. Number 3, 24 joules of energy is expended in moving 2 coulombs of charge a distance of 3 meters in an electric field. What is the potential difference through which, potential difference is V. So V is equal to W over Q, which is 24 over 2, which is equal to 12. That's an equation from the last chapter. I have to see if I put that on the test this time too, because that's from the last chapter. Okay, number 4. In the circuit below, the potential difference. So potential difference is V across the 4 ohm resistor is, so I want to find the potential difference across here. I want to find V. Now I'm going to look at this circuit. This is parallel. How do I know it's parallel? Coming out of the battery, what's going through here, the current, it splits. Some goes here, and then it meets up here. So this is in parallel with that. When things are in parallel, the voltage is the same throughout. So if the battery is 12 volts, this is 12 volts through here, and this is 12 volts. So again, I don't even need to do a calculation. All I need to do is recognize that these two resistors are in parallel. So if you notice for question number 1 and question number 4, it's just recognizing the relationship between the resistors and what's the same. Number 5. A physics student is given 3 12 ohm resistors with instructions to create the circuit that would have the lowest possible resistance. The correct circuit would be, now we know that if I was to add them in series, RT would be R1 plus R2 plus R3. In parallel, 1 over RT is 1 over R1 plus 1 over R2 plus 1 over R3. So because I want the lowest possible resistance, remember, if you want, you could calculate it, but you shouldn't have to do that. So if I actually calculated the equivalent resistors, remember, I want the lowest possible resistance. So if I have three 12-ohm resistors, 12 plus 12 plus 12, 12 and 12 is 24, plus 12 is 36, would be if they're in series. If they're in parallel, would have 1 over RT is 1 over 12 plus 1 over 12 plus 1 over 12. 3 over 12 are reduced to 1/4, so 1 over RT would be 1/4, and if I cross multiply, RT would be 4 ohms. So my lowest possible resistance is going to be in parallel. But just from doing problems, you should probably even know that. But here, we would see the answer is D, a parallel circuit with a total resistance of 4 ohms. Number 6, a 10 ohm and 20 ohm resistor are connected in parallel to a constant voltage source. If the current through the 10 ohm resistor is 4 amps, then the current through the 20 ohm resistor is now, there's different ways, again, to do this depending upon how you look at it. So, in parallel, if I wanted, I could draw a picture. So, I have a 10 ohm and I have a 20 ohm that are connected in parallel to a certain voltage source, which is constant. The current through the 10 ohm resistor is 4 amps. So what I could do is, if I know that this is equal to, this is I, and this is R, what can I find? V. So V is equal to IR, so 4 times 10 is equal to 40 volts. So if this is 40 volts, I know that in parallel, the voltage is the same. So if this is 40 volts, this is 40 volts. So if I know the voltage and I know the resistance, I can find the current. So I is equal to V over R. So 40 over 20 would be 2 amps. So the answer to number 6 would be B, 2 amps. Sometimes with circuits, when they tell you series and parallel, draw a schematic. You see how long it took me to do that schematic? Did that take me 10 minutes to do? No. And all the numbers on the test, on the multiple choice like this, just like your quiz, they're easy whole numbers that you can do the math in your head. But you don't want to make a mistake, so you can just write it on paper. But when I say in your head, I mean you don't even need to do your calculator. You can do 10 times 40 in your head. You can do 40 divided by 20 in your head. Number 7. In the circuit diagram below, ammeter A measures the current supplied by the 10-volt battery. The current measured by ammeter A is, so when I look at this circuit, I see that this circuit is obviously parallel. Whenever I'm doing a problem, if it's not a combination circuit, the first thing I'm going to say to myself, is this series or is it parallel? So I know that in parallel the resistances are reciprocal. So 1 over RT is equal to 1 over so there's two 40 ohm resistors. So 1 over 40 plus 1 over 40 is 2 over 40, which reduces to 1 over 20. See how I'm doing it again in my head? But remember, this is in parallel. So many of you made this mistake. You have to cross multiply. So RT comes out to be 20 ohms. So the total current coming out of the battery, IT, is equal to VT over RT, which would be 10 volts over 20 ohms. So the total current would be 0.5, which would be C. Number 8. A student needs a 4 ohm resistor to complete a circuit. Only a large quantity of 1 ohm resistors are available. Which of the following should be done to complete the circuit? So when it says a student needs a 4 ohm resistor, so now I want to see what is equivalent, what would be equivalent to the 4 ohm resistor. So whether we call this effective, sometimes what we do is I call it T for total, just because it makes it easier. Or you can call it equivalent. You can call it anything you want, but that's what we want to find. So if I just have, so RT would be R1 plus R2 plus R3 plus O4. So RT would be 1 plus 1 plus 1 plus 1, which would be 4 ohms. So 4 1 ohm resistors in series would be equivalent to a 4 ohm resistor. And that would give me what I need for this. And now we have to do the other problems on the back.